Now, pretty much every microwave oven or most microwave ovens are going to have some sort of way of making sure that the door is closed so that it doesn't, I don't know, radiate the rest of the room. So it's got to have a sort of switching mechanism of some sort to indicate that it is closed and that it's sealed safely. So you've got these little things here which are obviously going to go into there to activate the switches. And they come around and you've got 1, 2, 3 switches here, and if you watch the action, that's pretty much how it works. You see the 1, 2 red aspects to it, and on this one there's only just a little red one in there, and if you watch it now, there we go. Now the key with testing these switches is get yourself on, do continuity. It's pretty much the diode, which also comes up with a test tone on it. You can also do resistance testing, but the nice thing about using this is that it's a quick way, surefire way of actually being able to do it without having to see the screen. But what I'll do is I'll try and have it so that you can see both. So all you're doing is you're just removing each of these. Clearly remember where you put them. The good thing about these is that the wires have been in there for a while, so they're pretty much only got to go one place. You know, I can't put that one back onto there, and I can't put that one onto this one. So the only one I've probably mixed up is these two. So I'm just going to keep them pretty much in their same configuration. Now what I'm going to do is attempt to test it with my one hand if I can. So doing that, at the moment I'm getting nothing, open line, so that's good. And then clearly to test it, yeah, you're here, I'll close the door, and there we go. So that's it closed, that's it open, and the switch has been made. Now the thing to also note is if you take a look on the side of the switch, there we go, you'll see it indicates there basically what the switch is in its normal position, and then what it'll be like once it's closed. Sorry, other way around. Once it's closed, what it's going to do and what it is in its normal position. So this switch is NO, which means normally open, and then you've got your common, which basically goes through for when it's closed, then you'll get your continuity. Looking at this one, a little bit darker, but as you can see there, once again, it's a normally closed switch. And then once activated, it'll go to open. So let's test that, see if I'm talking rubbish or not. So there we go. So I think I said it the right way around. So basically once it's, no, I said it the wrong way around. Sorry about that. It basically means that once you close it, it's going to go to, so close, so that's a normally open switch, which once closed is going to be go to normally open, we'll go to open. And then finally the last one. Now this one you can see on here some of the writing. I'll just try and get that zoomed in there. So you've got common, and in its current state it should be normally closed, and then once you essentially open the switch, it'll break that connection, and you won't, and then you should get it thing. So testing it now with my trusty one-handed activity. Yep, there we go. So you can see, oh wait, there we go. So as you can see there, apologies, it is it's normally closed. Close the oh, stand by. Close the oven, and it goes to open line. There we go. And if I open again, it goes to normally closed. So these three switches are all working fine. From there, I basically moved around to the back. Oh, that's the contacts touching themselves. Okay, now some of you could sit there and say, well, why wouldn't you check these first? So you got a couple of fuses here, you got one there and one here. You're more than likely going to have a couple, especially on your power supply. So this is the power supply board. and that goes through, so you can see where, well, you can see your mains coming in, goes into the power supply board, and then that'll distribute it accordingly, obviously either regulating it or rectifying it accordingly to what needs DC and what needs AC as it goes through. Then that comes through to here, which then feeds your magnetron, and that's all sort of controlled by the control boards, which are basically activated by you as the user in the front. So I'm going to put these back, otherwise, so that I can go back there. That can go back there, and that can go back there. Sweet. Okay. So anyway, I'm going to teach you guys to suck eggs. I basically pulled this fuse, so that's not actually the correct fuse. I've now got the correct fuses for it. Pulled that fuse, and the fuse that came out was blown. So I figured, oh, easy fix again. Change the fuse out. Figured a bit annoyed that I'd gone to the thing of checking all the other switches. Put that one in, went to test it. Once again, would only work for about 3 seconds, then turn itself off. So I thought, okay, what's going on here? So I went and checked the other fuse, and I thought, nah, that one's fine. You can, if you have a look there, you can actually probably still see the filament right through the middle. So I've got the replacement fuses for this anyway. So what I'll do is grab that out. I bought like 2 for £1 or something. So, I mean, easy win. And got the correct ceramic one, comfortably placed. And clearly you should probably do a little continuity test just to make sure that they're all clear. It's probably worth not doing it with it, there we go, in the circuit, because they'll normally, the circuit could actually close the test for you and you could get a false reading. But I know that the switch is good, it's just the sake, that fuse is good, just for the sake of it. So anyway, fuses wise, we're all good there. Then you've got the other one, which is another switch, which is essentially a thermo switch. And this basically is your kick-in. It kicks in once your magnetron is getting too hot. So if you're trying to have a go at, like, heating the world with everything, you go and put your it'll run your magnetron too hot, and your magnetron will kick this switch out, and it'll kill everything, and then allow time to cool down. And so that's got to be normally closed in its standard configuration, and then once it gets to temperature, much like a thermostat in a car, it'll then kick in and turn off. And obviously your microwave won't turn back on again until this switch has cooled down and made contact again. So it's obviously some sort of bimetallic strip or something in there, whatever design they use. I mean, the fundamentals of electrics and electronics haven't really changed. It's just the ability to make them smaller and more efficient. And obviously we've got mass production in China and all that, as you can see with the writing. So anyway, now that comes down and it brings us through to the magnetron. Now with the magnetron, the thing with it is essentially that's normally your last port of call. You've tried everything by the time you get here, and the way to test it is you disconnect it from all the things that are associated, connected to it. You could do with removing it to make it easier. It's only 1, 2, 3 screws, and then a couple of connectors, which I've disconnected. I'd say, obviously, we're quite a ways into this now, but make sure you've disconnected your oven for a while, and you're not got any capacitors that are charged. Anyway, that's made connection there. So the first thing I'll show you is that I'm showing 3.5 ohms of resistance. Now, that should be less than 1 ohm of resistance to start with. Now, interestingly, after I did my test with the fuse, that was up in the kilo ohms area. The second test you do is from both terminals. You basically take it down and you touch the body of the magnetron, and at no point should you be getting any sort of continuity. It's pretty much should be open line. So if you're getting anything, then you've got yourself a short. Now I'm just trying to put it in a way that it'll stay in here for a bit, so I can carry on with the test. So if you look there, look at that, 11.74 kilo ohms. That's failed. and that's just to the body, and I'll test the other terminal, but either terminal is a fail, and both of them 11.75 kilo ohms. Now I appreciate that might be because it's still mounted to the microwave. I don't think that'd be the case. I don't think it should be making that happen at all. So what I've got to do is I've come to the conclusion that it's the magnetron. So go to my trusty parts bin, wabam, and out comes brand new Panasonic branded magnetron. I think it was 40 quid delivered, and surprisingly did quite well. Got it off the old Fleabay. I'd have to say I get everything off eBay now. And what we'll do is we'll pull that out. I'm going to put it in just on its side so I can do the test without possibly damaging anything. There we go. Let's get the old trusty multimeter. Favorite tool. And what I'll do is I'll set that up on its stand. Actually, I haven't used that in ages. And I'll go with the test. Now, you guys are fortunate enough, I literally have just pulled this out of the box and go for a resistance test. Now, I'm expecting this to be less than 1 ohm. And there we go. And oh, that's a bit high. It's not a good start. So let's test the body. Okay, that's interesting. Okay, so the interesting thing there was, I'll tell you what, let's have a little test here. Okay, so I've got 6.5 ohms just in my resistance. Clearly my connectors could do with being a bit better, but still a bit disconcerting that I got such a high reading. 5.3. Okay, so that, I assume that's probably less than 1 ohm.